Okay, Assalamu alaikum. Let's start with the new lecture that is about normalization of database table. It is in the book, it is chapter 9, but if we look at the slides, in the slides they make it as a chapter 6. I don't know why, what's the problem with it, but let's start with this new chapter. Okay, now we know that if we have a good database design, then it should must match to a good table structure. We know that we have ER diagram. From ER diagram we map that ER diagram to what? Tables. We create tables out of entities. Okay, so if we have good database design, then we should have a good table structure. So in this chapter we will learn that how to evaluate and design good table structure. Okay, it's not like necessary that after you draw a ER diagram and map to the table, your tables are always in a good table structure. No, it's not necessarily to be in a good structure. So what we have to do is we have to evaluate our table structure to convert them into good table structure. Good table structure will have very less redundancy. Okay, and there will be no anomalies. We know we have three types of anomalies: insertion anomaly, deletion anomaly, and updation anomaly. So if we have a good table structure, first thing, it will not have redundancy. Second thing, there will be no anomalies. And the process that produce this good table structure is called normalization. So we will learn normalization in this chapter. So in the start we will just discuss what is a normalization, what is its importance in database design. Then we have different normal form, starting from first normal form, second normal form, third normal form, BCNF, 4NF, and sometimes 5NF also. So we'll go for just first NF to 3NF. Rest of the normal forms I will not discuss, because these require, like, most of the time we do not require them in our business processes. And also we will discuss denormalization, which is opposite to normalization, where we deliberately add some redundancy into our tables for the purpose of efficiency. So we will discuss that also, that is denormalization. Okay, let's start with database table and normalization. As we know that when we perform data modeling with ER diagram, it should produce good table structure. But as I told you, it is possible that after mapping our ER diagram to the tables, we come up with the poor table structure, even if we have a very good ER diagram or database design. So how can you recognize that a table structure is poor? And how can I change this poor table structure to a good table structure? So the answer of both these questions involve normalization. Okay, so in normalization you can recognize a poor table structure. If you have a poor table structure, you will find out, and then you know how to convert this poor table structure to good table structure. So this is what a normalization is. So in formal term, we can say that normalization is a process for evaluating. Evaluating mean to find out, to recognize the structure of table, whether it is good or not. Okay, for evaluating, and then correcting table structure. If it is not good, how to correct it, so that we can have minimum data redundancy, and we want to avoid data anomalies as much as possible. Okay, as I told you that normalization work through a series of stages. Okay, we start with first stage, then go for second, then third. Okay, so first stage is called first normal form, second is called second normal form, and third stage is third normal form. And we can have even higher normal forms, but most of the business processes require our data base into third normal form. Third normal form is enough most of the time. Any question? No question. Are you listening to me?
Yes, Doctor.
Okay. From time to time give your feedback so that I'm sure there is somebody listening here. Okay. So as I told you, we have three normal forms. First, second, third. Okay. Now, second normal form is better than first normal form. And when we change our structure to third normal form, it means third normal form is better than second normal form. Okay. And as I already told you that most of the business design processes only need third normal form. So we perform normalization up to third normal form. We will not go beyond it. And that is what the highest level of normalization that is required for most of the business processes. And yes, we can have more normal form like BCNF, 4NF, 5NF, but in most of the business organization, this high level of normalization is not required. Okay. Then denormalization. Denormalization mean we have a database in third normal form and we change it to lower normal form 2NF. Okay. Or we have a 2NF and we change it to 1NF. Sometimes we have to perform this denormalization. Denormalization produce lower normal form. Okay. And why we need denormalization? For efficiency. Because when we remove redundancy, when we perform normalization, we remove redundancy. When we remove redundancy, it means that if we want to search answer for some query from our database, you might have to search answer of that query from multiple tables. Answer is not present only in one table. You have to go through, or your system has to go through multiple tables to answer the query answer. But what happened as a result of it? When we minimize redundancy, efficiency will be affected. Okay. It takes more time to access data from multiple tables. Instead, if your data is present in one table, so denormalization some time is required when we want to increase performance. Okay. Performance will increase as a result of denormalization, but the disadvantage of it will be it will increase data redundancy. Okay. For this discussion of rest of the lecture, we will go through this example. We consider a simple database activities of a concentration company, and this company have several building project. Okay. It's a construction company, and this construction company have many building project, and each project has its own project name and project number, assigned employees, how many employees are working on that project, and after that each employee has a employee number, name, job classification, like if this employee is a engineer or a technician. Okay. And another thing is okay, this information is given here in this table. You can consider as a table or a sample report. So this report is generated from a table that is used to for a construction company. One table is there. All information is there in one table, which include like here project number, project name, employee number, job class, charges per hour. Okay. Are billed, and total charge. Total charge is the attribute which is a derived attribute, and we derive this attribute by multiplying charge hour with hours billed, because our company charges its client by billing the hours spent on each contract. Like here on evergreen project, employee number 103 work on this project for 23.8 hours, and per hour charge for this employee who is an electrical engineer is 84.5. so the total charges for this employee is $2,1100.10. Okay. So you got it. It's a derived attribute, total charge. It is not the part of database. Okay, so this is the example table that we are going to discuss over here. Any question, anything? related to it? No question.
Doctor, for the total charge,
Yes.
how did you assume that it's derived? Because it has a field in the table, so why isn't it type of entity or something?
No, right now this is not a table. This is what? This is a report which we generate out of table. Table have only these fields which are over here.
Okay.
This field we generate in the report. Okay, it's a derived one. Now you can see that there are some employees in this table which are working on more than one project. Like if we can say, see here, this employee, Darlin. Darlin is, oh my god, today we got something new, you know, this is our tab where we can write also. This Darlin is working in project Amber Wave, and here also on star fight, employee number 112. Similarly, employee number 105, okay, where is 105? Yeah, this one is also working here in this project. So it is possible that there are more than one employee working in a project. Okay, now if we look at the structure of this table, you will see that we have some anomalies over here. Okay, like update anomalies. If I want to modify the job class for employee number 105, okay, this employee 105, if I want to change his job class, how many possible alteration require? He is database designer. I want to change his job class from database designer to something else. So I have to update how many records? This one, then this one, 2, and if he is occurring in any other. So update anomaly is we have to modify multiple records in case if we want to update a record of only one employee. Okay, insertion anomaly. Okay, if a new employee is added, okay, your company hire a new employee, but this employee has not being assigned to any project yet. So then what happened? If a new employee is being hired but he has not assigned any project, so we cannot add this new employee into our database until we do not assign him to a project or dummy project or whatever. So this is what insertion anomaly here. Deletion anomaly. Okay, if employee leave the company and employee data are deleted, then the project information will also be deleted. Like if there is one project on which only one employee is working and that employee leave the company, we delete the information about that employee. Along with that, we will have to we are deleting the information of project as well. Okay, so this table is not in a good shape right now. We have to make some changes into it. We have to perform normalization on this table. Okay. So as I already informed to you that this table is not in a good structure. Maybe it appears that it works properly, report is generated, but report might produce different results depending on what data anomaly that I already discussed with you has occurred. So you know, we need to perform normalization on it. Okay, the objective of normalization is to make it sure that each table conform to the concept of well-formed relation. Table and relation mean same. In database terminology, we called table a relation. Okay, so in the book also they use both terms interchangeably. Sometimes they call it a table, sometimes called it a relation. So they both are same thing. Okay, so each table, when we perform normalization, we want it to represent a single subject. Like in the previous table, if you can see here in the previous slide, yeah, here, this table, if this is a table, it is not representing a single subject. Single subject can be either a project, or single subject can either be an employee, or a single subject can be either a job, type of jobs we are offering in our company. But here this table is presenting multiple subjects. But when we perform normalization, the first objective of normalization is that when you create a table, that table represent only a single subject. Second is, no data item will be unnecessarily stored in more than one table. Why? The reason for it is that we want to make it sure that data are updated in only one place. Because if we store a same data item on multiple tables, it is what? It is adding redundancy. So when there is a redundancy in our table, it means that if whenever we want to update or delete any record, we have to do it from multiple places, and we don't want it because there is a chance of error in it. Okay, the third requirement of normalization process is all non-prime attribute in table are dependent on the primary key. Non-prime attribute are those attribute which is not a primary key. We have different attributes in the table, like here, you know, in this table we have attributes project number, project name, employee number, employee name, job class, charge hour, hours billed, total charge. What can be the possible primary key in this table? Who will tell me?
Project number.
Okay, project number currently in this form, yeah, we can have a project number as a primary key. So this is a prime attribute, and all other are non-prime attribute. Other than project, all other are non-prime attribute. So in normalization process, what we want is all non-prime attribute depend on the primary key. So does employee name has anything to do with project number? Is there any dependency of employee name with the project number? No, employee name does not depend on project number. Okay, so in this scenario, if we look at it, there is no non-prime. Employee name is a non-prime attribute, and if our primary key is project number, so non-prime attribute should depend on primary key. But here in this case it is not. Okay, but when we perform normalization, then it will. Okay, and last property or requirement for the normalization process is each table is void of insertion, update or deletion anomaly, because we don't want to have any insertion, updation or deletion anomaly, because if such kind of anomalies are present in our database, it add inconsistency. So we want to ensure integrity and consistency of the data. So we want to avoid these insertion, update and deletion anomalies. Okay, we know that we have different normal form, starting from first normal form, then second, then third, then BCNF and 4 normal form. And we will discuss up to third normal form. Rest we will not discuss in this course. Okay, from the data modeler's point of view, the objective of normalization is to ensure that all tables are at least in third normal form. Okay, so when you are going to design your database, you must have to make it sure that your tables are at least in third normal form. Higher normal form exists, but as I told you, most of time these are not desirable in our business processes. And normalization process, when we perform normalization with one table or one relation at a time. Okay, we will not do it all together. We will perform normalization one relation at a time. We will have to find out in that particular relation or a table what are the dependencies and how to remove them or how to normalize this relation. So normalization process start by identifying the or finding out the dependencies of a given table or a relation, and then we will progressively break up the relation. Break up the relation mean we will create from that table multiple new tables based on our identified dependencies. Okay, any question until here? Okay, no question. Okay.
Doctor,
Yes.
could you please explain once more what's a dependency? Because every entity is related to other entities, so there must be a dependency at the end.
Dependency I will explain in the coming slides. This concept is being
Okay,
explained in more detail. Yeah,
inshallah.
just wait. Next slide immediately is dependency. Okay, we have the concept of functional dependence and fully functional dependence. Okay, now as you ask me like what is the dependency concept, so a functional dependence is a relationship between two attributes, typically between the primary key and other non-prime attribute in the table. Okay, so functional dependency is a kind of relationship which we build between primary key and non-prime attribute. And for any relation R, attribute Y, okay, I think I should write it. For any attribute R, any relation R is our table, okay, relation R, attribute Y is functionally dependent, we will write it like this, on attribute X. Now X is called determined, this is determined, and this is what? Dependent. Okay, this is determinant, determinant, okay, determined nahi, okay, I don't know how to use this thing. Okay, determinant and dependent, and we write it like this, Y is dependent on X if for every valid instance of X, that value of X uniquely determine the value of Y, and it is represented like this. The left side is determinant and right side is called dependent. Okay, like here, this is an example. Project name is fully dependent on project num. Project name depend on project num. Project num is determinant and project name is dependent. Okay, in other words we can say that if I give you project number, could you find project name from the table?
Yes.
Yes.
Probably.
Yes, by given a project num, we can uniquely identify a project name. Okay. Another example, student table. We have a student ID and student name. Okay. Given student name, can you find out all the information of that student? Or student ID, okay. Given student name, can you identify that student ID?
No.
No.
No. It is possible there are two students with the same name. So you cannot uniquely identify student ID from student name. So student ID does not depend on student name. Functional dependencies we find out by only considering primary key attributes, and then we look at all non-prime attributes and see that is every unique instance of primary key attribute identify a unique instance of non-prime attribute. Like if I give a student ID, I can definitely find all the information about that student without any doubt. Okay, got it? This functional dependence concept. Okay, then we have fully functional dependence. What is a fully functional dependence? Now fully functional dependence, here you can see composite key. So we if we have a composite key, we know that composite key consists of 2 or more attributes. So then we have to see that is like in this previous table, if we have our primary key as project number and employee number. Oh god, I don't know, I do something wrong with this pen. Oh, shit. Employee number. Okay, this is our composite key, and then we have all other non-prime attribute. So if we have composite key, then fully functional dependence mean that each non-prime attribute should be fully functionally dependent on both, like here on project number and employee number. So if I say employee name depend on employee number, but it doesn't depend on project number. So there is no fully functional dependence of employee name on both of it. Got it? Okay. Okay, when we look at functional dependence or fully functional dependence, then we come up with two more concepts. Okay, we have two types of, when we say functional dependency, the two types of functional dependencies are partial dependency and transitive dependency. Now partial dependency, like I just gave you an example of employee number and project number. It exists when there is a functional dependence in which the determinant is only on part of the primary key, like here. Okay, we have a good example over here, like this one. Okay, we have student number and course. This is our primary key, and these are the non-prime attributes. Now if you look at the non-prime attribute, student name depend on student number, but does student name depends on course? Student
No.
name depends on student number. Okay, we have this dependency here. I don't know, but it has nothing to do with course. So here what we say, if we have table in this form which have these two attribute as primary key and these are non-prime attributes, there is what? There is partial dependency. Okay, got my
Yes.
point? Huh.
Yes,
And
got it.
then we have transitive dependency. Control F4. Huh. This is okay. Transitive dependency, when there are a functional dependency such that y depends on x and z depends on y. Okay, and x is the primary key attribute. Now what we have in the transitive dependency, that x is the primary key attribute. X is primary key, y is non-prime. Okay, it is non-prime attribute. Y depends on x, and then y is a non-prime. It takes time to learn this. This is non-prime and z is also non-prime. A non-prime attribute depends on another non-prime attribute, and that non-prime attribute depends on prime attribute. So then it is what? X z is dependent on x, but this dependency is transitive dependency. Why? Because z is not directly dependent on x. Z depends on x based on a non-prime attribute y. Okay, here we have an example. Program name and program ID and student number. Now program ID and student number have dependency, but program name depends only on what? Program ID. It has nothing to do with student number. So this is what? Transitive dependency. Program ID depend on student number and program name depend on program ID. Okay, let's start with first normal form. Like we want to convert our database to first normal form. So when we are going to convert a first normal form, first thing we need to look into our existing table structure. Okay, another thing I want to tell you. Now normalization, when you perform normalization, you can perform normalization. You have been given already existing files and ask you to perform normalization on it, or you have been given a ERD diagram, entity relation diagram, and asked to do normalization on it. Okay, you can perform normalization in two situations. Okay, you have already a table structure given to you, already files and Excel sheets are there and tables are already created, and you have been asked to convert it into normal form, or you have been given ER diagram and asked you to convert it into normal form. So there are two situations where you have to do normalization. Okay, in any case when you want to convert to first normal form, first thing that you have to do is you have to look at the repeating group. Now repeating group derive its name from the fact that a group of multiple entries of the same time can exist for any single attribute occurrence. Okay, this is formal definition, but simple explanation of it is over here. Okay, this has become very dirty. I need to clean it, huh? Let me clean this table because we need this table now. Okay, now here we have repeating group. What is repeating group? We have one project number. Okay, one entry here as a project number, evergreen or whatever, and we have multiple employees number over there for it. Okay, this is better. We have one project name and we have multiple repeating groups over here. Okay, another one employee number or employee name and multiple entities for it. So this is what? This is a repeating group. Like for evergreen project number 15 shows 5 entries, and all those entries are related because they each share a project number 15. So each time when a new record is entered for the evergreen project, the number of the entries here, right now it is 5, it will increase to 6, then to 7, then to 8. So this is what? Repeating group. Another repeating group is over here, another repeating group is over here. Okay, so first thing, when we are going to convert to first normal form, we have to look into our table that if we have a repeating group, first thing we have to do is to remove these repeating group. Okay, how to remove the repeating groups? So when we are converting to first normal form, we need to remove repeating group, and normalizing table structure will reduce data redundancy. When we will perform this or delete this repeating group, it will remove data redundancy. So there are 3-step procedure in normalization. Step 1, eliminate the repeating group, and if you have any nulls, that should also be eliminated. Second step, when you are converting to first normal form, you have to find out the primary key of the table, and you know that what mean by primary key? Primary key must uniquely identify attribute value, and that key can be composite attribute key as well. Okay, so our new key must be composed. So when we are converting to first normal form, step 1, eliminate the repeating group. Second step, find out the primary key. And third step, identify all dependencies. Dependencies both transitive and partial. We have two type of dependencies, partial dependency and transitive dependency. You don't have to remove redundancies, just need to identify them, that okay, we have these redundancy in this table. Okay, let's do it in the same table. Okay, now in this table we have removed the repeating group. How we remove the repeating group? Now wherever we have project number 15 and all entries grouped together, instead of it we put all of them in a single cell. Like first, second, I create 5 entries here for project number and project name, and then we add it over there. Okay, and same we have to do for the rest of the entries. So now repeating groups have been eliminated. Okay, got it? If you know, you can compare both, how to remove the repeating groups. Okay, this table has repeating groups, these are repeating groups. How to remove these repeating groups, eliminate these repeating groups? You have to do it like this. Okay, you have to add for each row this value where there is one value in one cell. You will not have multiple values in one cell, like 15 evergreen and 5 values over here, 5 values over here, 5 here, 5 here, 5 here. No, each intersection of row and column should have a single value. So we have single value in each cell. So repeating groups have been eliminated. Second step is we have to identify the primary key for this new table. In the previous table, project number was enough as a primary key, but in this new table structure, project number is not a sufficient primary key because this project number is repeated. You can see here it is repeated, so it's not a good primary key. So what can be now primary key? New primary key, we can see that project, yallah, this is not good, project number and employee number. These two attributes together are unique for each row, so we can have these two attributes as a primary key, or we have a composite primary key right now. Okay, this is our composite key. So we have eliminate repeating group, we have identified primary key. Now what should be the next step? We need to identify the dependencies. Okay, so in order to identify the dependencies, we need to draw dependency diagram. It is very useful to draw dependency diagram to find out the dependencies, because if you draw dependency diagram correct, then rest of conversion to second normal form and third normal form is very simple. Okay, so how to draw dependency diagram? Okay, this is the way to draw dependency diagram. You write all the attributes of the table over here and underline the primary key. Our primary key is project num and employee num. Okay, on the top side of this table kind of thing, we have this okay, let me show it over here. Okay, you have to identify. Okay, how can I go? Okay, here these are our primary keys, and we want that all this is desirable dependency. This is what? Desirable dependency. We want that all non-prime attributes should be fully functionally dependent on prime key attribute. Okay, so on the top we draw desirable dependency, and here on the bottom side we draw actual dependency. Desirable dependency is we want all non-prime attribute to fully functionally dependent on prime attribute. Okay, now what kind of dependencies exist in this table? Okay, we can see that here we have one partial dependency. Project name depends on project num, not on employee num. Similarly, another partial dependency we have, employee name depend on employee number but not on project number. Similarly, job class and charges per hour depend on employee. It has nothing to do with project. Okay, because job class, what is the job class of employee? Job class has no relation with project. And what are the per hour charges for that job class? Also depend on employee, not directly employee but transitive dependency. Here you can see transitive dependency. We have job hours depends on job class. Okay, excuse me, let's finish it. So after drawing this dependency diagram, our database is in first normal form. So second step that we have to do is we have to convert it into second normal form. Okay, so conversion to first normal form, we already converted to first normal form, like all key attributes are defined, no repeating group in the table, all attributes are dependent on primary key, and all relational tables satisfy first normal form requirement. So when okay, if you have only a single attribute as a primary key, then it means you don't have to go for second normal form. Your table is already in first normal form. If you see over here, in second normal form we remove partial dependencies. So if our table, some tables contain partial dependency, and dependencies are based on part of the primary key and should be used with a lot of caution. Because if we have a single attribute as a primary key, then there will be no partial dependencies. So our table is already in second normal form. But if we want to convert to second normal form, so what are the steps to convert to second normal form? First thing is your table should already in first normal form, because you cannot go directly to second normal form. You must have to go in step by step. First normal form, then first normal form to second, then second to third. So first thing to convert to second normal form is your table should already be in first normal form. And if your primary key just consists of a single attribute, it means you don't have partial dependency. So your table is already in second normal form. You don't have to convert it into second normal form. It is already there. But if you have a composite key and you have partial dependencies, then you have to change it to second normal form. Okay, what are the steps to eliminate partial dependencies? Okay, first thing, you have to write each key component on separate line and then write original key on last line. Okay, this thing I think I will discuss in the second lecture on Sunday. So until here we finish until first normal form. Okay, second normal form, third normal form I will discuss, because if I will leave it in the middle, it will not be good, and we have only 5 minutes. So
All right, thank you.
okay, thank you, then take care, bye bye.